Hi guys, welcome to my YouTube channel. Today I'm going to teach you about thermal physics or thermal expansion, volume expansion, area expansion, and also there's a contraction. So first let's start with linear expansion. So what is linear expansion, right? So a linear expansion occurred when the temperature increase in some object which has this length. So for example, meron tayong metal rod dito. So, meron tayong L0, which is yung initial length niya before a heat was applied, maybe heat or maybe the temperature increase. So, this is L0. No, I'm gonna write this better. Oh, this is too big. Make this smaller. So, ito ang L0. And ito yung initial length niya. Here. Sabihin natin ito yung initial length. Also, this thing will increase in width also. There will be an increase in the width, but that will be later. So, kapag nag-apply tayo ng heat dito, what will happen is mag-i-increase yung length nung object nito. The specific object will increase in length. So, here. So, kunwari nakapag-apply na tayo ng nag-increase na yung temperature niya. So, ito yung magiging niya, of the final length if that temperature was applied. So, here. So, nag-increase siya. Ganito na siya. And then, here. So, what if naman kapag the temperature was decreased? So, magkakaroon tayo ng linear contraction. Linear contraction, I think that's it. But this is also, yeah, we would have a linear contraction. So, pwede rin siyang maging ganito. This will become the final length. And there's a significant decrease sa kanyang length. And ito naman yung yung change in length, which is meron siyang equation. I will tell the equation later. Here. So ito yung change in length. So the equation, let me write the equation. So we're going to use this equation to answer some practice problems regarding sa linear expansion and contraction. But I think puro expansions tayo ngayon. Pero same thing pa rin siya ng calculation. So the change in length is equals to alpha, which is the linear coefficient. I will name this later. And the initial length times the change in temperature. So ito ay the change in length. So as you can see, dun sa illustration, the left side, it's basically the change in length. Na itong nasa itong mukhang na to is alpha, Greek alphabet symbol. And this is the linear coefficient. So this is the coefficient. It's a constant actually. Every object has a coefficient, a linear coefficient. Maybe volume coefficient kapag tawag sa tabla. But yeah, so every object has that. It's a constant. So this is the initial length. And ito naman is yung basically the change in temperature. You can write it sa temperature in final and minus temperature initial. Change in temp. Okay. Now let's move on to some practice problems. Oops, okay, so let's say this. Let's have a problem. An aluminum bar is 1.25 meters long at 25 degrees Celsius. The coefficient of linear expansion is 25 times 10 raised to the negative 6 divided by degrees Celsius. If the temperature is increased to 100 degrees Celsius, how much will be the length of the aluminum bar change? What is the due length of the bar at this temperature? So let's just draw this thing. So meron daw tayong aluminum bar which is clearly 1.25 meters long sa 25 degrees Celsius. So that's this is the L nut. Here we can just put this here. It's 1.25 meters. So 100, wow. Sa 25 degrees Celsius in this temp. So 25 degrees Celsius. Malamig yun, right? Malamig yun sa Pilipinas. It's cold. Then yung linear expansion daw is 25 times 10 is to the negative 6. So we apply the heat. The temperature increase to 100 degrees Celsius. So the change in temperature is just 75 degrees. So what is the new length? The change in length. How much will be the change in length? So let's just use the formula. So change in length is equals to the linear coefficient times the initial length times the change in temperature. So let's just plug in all the things that we know. So we have a linear expansion coefficient of 25 times 10 raised to the negative 6. Ang initial length natin is 1.25. And the change in temperature is 100 minus 25. So what we're going to do is just put this in our calculator and we will find the answer. So I got 2.34. 2.34. So 2.34 meters. So yun yung change. Millimeters. So times 10 raised to the negative 3 yan. Gumamit ako ng scientific notation. Metric system. And that's it for this problem. So number 1. Now let's move on to number 2. So what is the new length of the bar at this temperature? So sa temperature doon na to, ano yung new length niya? So binaring ba ko yung inilis ko kasi mahalaga yun pala. So let me just delete these things here. Except sa change in length. Because with that formula, we can just basically calculate the new length of the bar sa temperature na 100 degrees Celsius. So change in length is, we can just define this as the final length minus the initial length. Change in length is 2.34. Ang hinahanap natin is yung final length. And the initial length is 1.25 siya. So we're just going to subtract this here. Don't forget the units. Millimeters yung isa. So we can just say this is times 10 raised to the negative third meters is equals to the LF minus 25 meters. And then what we're going to do is just add 1.25 to both sides of the equation. Use inverse property of algebra and then we get this answer. So, ang final length niya is 1.2534 meters. And that's it. So, this thing can be also changed inversely kapag nag-decrease yung temperature sa 0 degrees Celsius. So, dapat pala lagay ko volume expansion and linear expansion. But, nah, we're working for Boolean expansion lang. Problems for here. So, let's go to area expansion. So, area expansion is almost the same as linear expansion. We're just going to calculate some areas here. So, syempre, if we have a rectangular object. So, let's say this. Here, we have a W knot and the length knot. And then, nag-add tayo ng heat. I mean, the temperature increase. Why I keep saying add heat. Change temperature and heat are different thing, I think. So, change in temperature, nag-increase siya. So, nag-increase in temperature, therefore, mas nag-expand yung area niya. Also, if nag-decrease yung temperature dito, mas magdi-decrease rin yung So, bakit walang linear area contraction? Because we're just prioritizing the expansion in solids. This can also occur in liquids. And we can just use the same formulas to visualize them. So I'm not going to go on to those problems because we can solve a lot of problems though. So ito yung mga equation niya. We can just calculate individually yung length and yung width niya. They are just the same though. So, ang area, we know it in geometry or trigonometry, kung saan nyo naman nakuha yan. Ang area is just length times width. And then, we can just broke this down sa L naught plus W naught, which will become the area naught or the initial area. And then, the final area, which is the LF and WF. So, those are the equation for area expansion. Actually, I forget something like the change in area is just equals to the final area and the initial area. And that's it for this. Now let's move on and just solve this problem. Example problem. A solid plate of lead which has a linear coefficient of 29 times 10 raised to the negative 6. Dapat over degree Celsius yan is 8 cm by 12 cm at 15 degrees Celsius. What is the change in area and the new area of the lead plate if the temperature increases to 95 degrees Celsius? So, sabi dito, meron tayong plate of lead. And, binivisualize ko lang para makita nyo. So, meron tayong plate of lead. Ang initial length is 12 cm. Ang initial width is 8 cm. At the temperature of... Oh, wait. Oh, yeah. So, let's just quickly calculate the area here. Okay, so 12 centimeter. So 12 times 8 lang yan, guys. We're just gonna calculate the initial area. Ang hinahanap dito is yung new area and the change in area. But this is the first step in calculating this. Cubic meter? I think it's squared. Wait, let me delete this. So actually it's squared. Centimeter times centimeter is centimeter squared. That's why it's centimeter squared. So that's the initial area. Let me just put it here. So now, what's next? Let's now calculate the change in length, or I mean the final length of this thing. We also can derive the formula real change in area. But I'm not going into that. I want the hard way. So I'm just going to expand this and solve for the final length. So we got this. So we can just factor out the initial length. So we got 1 plus alpha change in time. And then there you have it. That's the formula for the linear expansion, the final length. So what we're going to do is just plug in all the values that we have. 12 plus the quantity of 1 plus the quantity of 29 times 10 raised to the negative 6 times the change in temperature, which is 95 minus 15. And put this in a calculator and we will have the answer. So the answer I got is 12.02784 centimeter. So that's the final. So now let's move on and calculate the final width. So yeah, this is a long-term process because we didn't derive the real equation. It will make things easier, but we can do that though. If you have learned algebra, you can just manipulate every equation that you want to manipulate. Now let's solve for the the final width. So let me just delete the diagram. So ito yung temperature, initial temperature dito is 15 degrees Celsius. And yung final temperature here is 19? No, it's 95 degrees. Let me just do it this thing. Oh my god, I'm kind of sleepy though. Okay. So we're going to calculate the final width. Okay, why did I put L? Okay, there we go. No. Okay, let me just deal with this. Sorry for the mistakes that I'm doing. Okay. So I just forgot I need to write the area because we need this. So we got 96 centimeter for squared centimeter. So yeah, let me just delete this. So I didn't put W not. It should be WF, which is the final width. So now what we're going to do is just the same as earlier. We're just gonna simplify the equation and solve for the final width. So here we got this and got this, and we just got this here. There we go. We're just going to transfer the initial length to the other side, which will make it a positive. And then next, let me just copy those things. Here I'm just copying them. And what we're going to do is just factor out the W naught. And then we got it. So this is the formula that we're going to use for the final width. So let's just plug in all the formulas that we know. What's the initial width? It's actually 8. So we got this. The linear coefficient is 29 times 10 raised to the negative 6. And then the temperature we have is 95 minus 15. So the final width We just use our calculator, our scientific calculator, magical calculator. And I got 8.015, 8.0156. Okay. No, I mean this is 8 and 56. It's centimeter. And that's it for this. So what we got now is the width and the final width and the final length. So unahin mo natin yung the new area because makakalculate na natin siya by AF equals to LF BF, right? So yeah, start with that. So I use this hard way because we can literally adjust the equations earlier. We can solve we can find for more much easier equation where we can just plug in things. But I did this so we can visualize on what is really happening. So I think this is much better if we're going to do this. But this is a long process. You can derive the formula later though, if you wanted to. Because it's easy to derive a formula. It's just a simple algebra. So the final area that I got is 96.4459 squared centimeter. And that's it for that. So now what we're going to do is just solve for the change in area. This is pretty much easy though, because we know the final area and the initial area, which is 12 times 8 is 95, 90 ano ba yan? 96. So as you can see, kahit mag-increase yung temperature niya na sobrang hot, konti pa rin yung change in area niya, no? Pero depende pa rin sa linear coefficient. But the linear coefficient is literally a small number. So this is not a significant or big change. We're just learning this. Now let's move on to volume expansion and the volume contraction. If you're going to put a negative sign, or I mean, if we're going to decrease the temperature, we will get a volume contraction. So yung volume expansion, you can say it's pwede rin siya sa liquid though. They call it volume contraction. But in this problem, in this video, I'm not going to into that because it's clearly the same. And you can also see it in my thumbnail. Yung water, which is decreased, was decreased because of a cold temperature. But in reality, it is just a small portion of it that will be decreased. Konti lang yung mababawas kahit gaano pa kalaki yung temperature. But I think the will change, yung malaking pagbabago is if nag 1,000 degrees Celsius na siya or negative 1,000 degrees Celsius. But I think the liquid will be frozen, right? And the water will be just evaporate. So what I'm talking here. So here I'm drawing things that we need to do. So volume expansion is just almost the same as area expansion and linear expansion. So kapag nag-apply lang tayo ng heat, they will just become, they will increase in volume. And if we decrease the temperature, what will happen is the volume will contract and decrease. So this temperature affects one's object. So this is actually my first video on thermodynamics. We will go on more. So the equation for volume expansion So here we will we will consider the bulk modulus that I have taught in fluid mechanics. So the change in volume is equal to bulk modulus times VO is initial volume and change in temperature, where the bulk modulus is just approximately 3 times the linear expansion coefficient. Now let's do a practice problem. So our rectangular solid of brass has a coefficient volume expansion of 56 times 10 raised to the negative degrees Celsius over degree Celsius dapat yan eh. The dimension of the rectangle are 5 by 6 by 8 at 10 degrees Celsius. What is the change in volume? And the new volume if the temperature increasing to 120 degrees Celsius. So 120 degrees Celsius, very cold na. So as the solution here, I'm not just going to give the illustration because you can just visualize it in your head. First, let's calculate the bulk modulus. So 3 times the linear volume expansion. So 56 times 10 raised to the negative 6. Yeah, and then here what we're going to this and we got this. So this is the bulk modulus. Bulk modulus is measurement of an object that to withstand its force. Okay, the change the initial volume now is 5 times 6 times 8. So it is clearly 240. So it just 240 feet, cubic feet. Kasi feet times feet is cubic feet. So here, we'll just put the change in temp. 120 minus 10 degrees Celsius. So the change in volume. So let's just use our calculator to finish this problem. So we got the change in volume is 4.4352 cubic feet. So that's the change in volume. So ano daw next is ano daw yung magiging new volume niya kapag nag-increase siya ng 120 degrees Celsius. So ito yung what we're going to do is just plug it in dito. So the change in volume is 4.4352. And yung final volume niya ay 4.3. Oh, what I'm doing? What I'm writing? Yun pala yung hanapin natin. Okay. Yung kanyang new volume, final volume. Wow, guys, I'm really sleepy. So there you go, yun yung final volume. And then, yung initial is 240. So, what we're going to do is just additive inverse addition. What is that called? And then we got this 244 point what 4352. And that's it. Thank you guys for watching. I hope you learned something in this thing, and good